Welcome to Astronomy Daily, the podcast bringing you the biggest news from across the cosmos. I'm Anna.
And I'm Avery. And today we're covering everything from unexpected setbacks to groundbreaking discoveries.
That's right. On the docket today, we'll be discussing a significant anomaly during testing for SpaceX's next-generation Starship booster.
Then we'll look at a mysterious stealth solar storm that struck Earth without any warning. We'll also dive into new research that suggests ancient Mars may have been habitable for much longer than previously believed.
And to round things out, we have an update on a Welsh startup testing a unique balloon-assisted rocket, and we'll check in on the Bepi Colombo mission, which is now just 1 year away from its destination, the planet Mercury.
Let's get started then.
It's a lot to get through, so let's start with the big news from Starbase.
All right, our first story is a major development in the Starship program. SpaceX has been preparing its next generation of boosters, known as Block 3, for testing. But they've hit a serious snag. On November 21st, Booster 18 was undergoing a routine gas system pressure test when its liquid oxygen tank ruptured.
Ruptured is a gentle way of putting it. From the photos, it looks like a massive hole was torn in the side of the vehicle.
Exactly. SpaceX confirmed the anomaly, stating that no propellant was on board and no engines were installed yet, but the damage is extensive. Early analysis suggests that a COPV, which is a composite overwrapped pressure vessel, might have failed at the bottom of the booster.
So one of those high-pressure tanks likely exploded.
That's the theory. It seems to have set off a chain reaction, blowing out other COPVs along a structural chine and leading to the main tank rupture. What's remarkable is that the booster didn't immediately tip over. It's currently being held up by the new, larger liquid methane transfer tube, and the teams are figuring out how to safely secure it.
That sounds incredibly precarious. So what does this mean for the program's schedule? This was the first of the new Block 3 boosters, right?
It was, and this failure leaves them with 0 completed flight-ready boosters. They'll have to shift their focus entirely to the next one in line, Booster 19. It's definitely not the start to the Block 3 era that SpaceX wanted.
Of course, but I suppose there's a silver lining.
There is. As frustrating as this is for them, it's far better that this happened during a ground test at their Massey site than during a 33-engine static fire on the launch pad, or worse, during an actual flight. This is why they test. They find the flaw, fix it, and make the next vehicle stronger.
From a failure on the ground to a disruption from the sky. Our next story is about a stealth solar storm that hit Earth on November 20th. It arrived almost completely without warning and was responsible for some beautiful auroras seen at lower than usual latitudes.
So what makes a solar storm stealthy? I usually think of them as these massive, obvious explosions on the sun.
That's typically the case. A regular coronal mass ejection, or CME, is very visible in solar data, often accompanied by a bright solar flare. Stealth CMEs are the opposite. They erupt quietly, without any bright signatures. They tend to be faint, slow-moving, and incredibly difficult to track.
So we often don't even know they're coming until they're already here.
Exactly. That's what happened on November 20th. Forecasters at NOAA only noticed it when they saw a disruption in the solar wind conditions around Earth. They called it an embedded transient. The magnetic field carried by the solar wind, which is normally around 4 to 6 nanoteslas, briefly spiked to 18.
That's a significant jump. And this, combined with a fast solar wind stream from a coronal hole, is what likely triggered those auroras seen in places like Maine and Denmark.
That's the leading hypothesis. This event didn't trigger a major geomagnetic storm, thankfully, but it highlights a known challenge for space weather forecasting. A 2021 study confirmed that these stealth eruptions can come from seemingly quiet regions of the sun, yet still pack a magnetic punch when they reach us. They're a quiet threat that scientists are working hard to better understand and predict.
Next up, let's talk about a different approach to reaching orbit. A Welsh startup called B2 Space has just completed a key test of its launch system, which is known as a raccoon.
A raccoon? As in a rocket and a balloon combined?
Precisely. The idea is to use a large, high-altitude balloon to carry a solid fuel rocket up through the thickest part of the atmosphere. Then, once it's at a very high altitude, the rocket launches. It saves a tremendous amount of fuel you'd normally use just to fight through that dense lower air.
That's a clever concept. So, what did this recent test involve?
B2 Space conducted the test from the Canary Islands. They launched the balloon carrying a smaller, lower-powered version of their eventual rocket. The balloon ascended to an altitude of 21.5 kilometers, that's about 70,000 feet, at which point the rocket successfully launched.
Incredible. Was the system reusable?
It was. The company confirmed that all elements of the launch system were successfully recovered after the test. Their next step is to repeat this test with a larger, more powerful rocket in April 2026. The ultimate goal is to have their operational system carry payloads of up to 200 kilograms to low Earth orbit, with the balloon releasing the rocket at an even higher altitude of 35 kilometers. It's a fascinating and potentially cost-effective way to serve the small satellite market.
From innovative launch systems to new discoveries on other worlds, our next story takes us to Mars, where new research is changing our understanding of the planet's past. Scientists at New York University, Abu Dhabi, have found evidence that ancient sand dunes inside the Gale crater were gradually turned into rock by interacting with underground water billions of years ago.
Wow. So this suggests Mars had liquid water for a lot longer than we thought.
Potentially, yes. The research team examined data from the Curiosity rover, looking at a feature called the Stimson Formation. These are what's known as lithified formations, basically sand dunes that hardened into stone. The thinking was that this probably happened during Mars's wet Noachian period, about 4 billion years ago. Okay, so what's new here? The team determined that these rock formations were actually the product of late-stage aqueous activity. This means the water that hardened the dunes didn't come from ancient floods, but from groundwater seeping from the nearby mountain, Mount Sharp, much later in Mars's history. They even found minerals like gypsum left behind, which points to this interaction with groundwater.
That's a huge deal. It extends the timeline for when Mars might have had liquid water and therefore been potentially habitable.
Exactly. And it gets even more exciting. On Earth, similar sandstone deposits contain some of our planet's oldest evidence of life, like communities of microorganisms. The research team believes that these lithified dunes in the Gale crater could be prime candidates for finding the preserved remains of ancient Martian bacteria.
So this not only rewrites a bit of Mars's geological history, but it also gives us a fantastic new target in the search for life.
That's right. It suggests these sites are where future missions should be looking if they want to find evidence of past or even present life on Mars.
Finally, let's check in on a mission that's been cruising through the inner solar system for over 7 years. The joint ESA and JAXA Bepi-Colombo mission is now just 1 year away from arriving at its final destination, Mercury.
It's been a long journey. The mission has already completed numerous flybys, 1 of Earth, 2 of Venus, and 6 of Mercury itself, just to slow down enough to be captured by the planet's gravity.
And even those flybys have produced great science. A key highlight has been the measurements of Mercury's magnetic environment. We're still trying to understand exactly how the planet's magnetic field works, and Bepi-Colombo has already given us the first measurements from low over the southern hemisphere, helping to build a better map.
And of course, we've gotten some incredible photos from the monitoring cameras, the so-called selfie cams.
Absolutely. But the main science phase begins in about a year when the 2 spacecraft, ESA's Mercury Planetary Orbiter, or MPO, and JAXA's Mercury Magnetospheric Orbiter, known as MEO, finally separate and enter their own orbits.
And this will be the first time Mercury is studied by 2 spacecraft simultaneously. Why is that dual approach so important?
It gives them a huge advantage. MPO will orbit very close to the planet's surface, while MEO will be in a larger, more elliptical orbit. This allows them to study how the solar wind interacts with Mercury's magnetic field from two different perspectives at the same time. MPO will be mapping the surface in incredible detail, determining its composition and temperature.
And it will also get a look at those permanently shadowed craters at the poles, right?
Yes, it will. Peering into those craters is one of the mission's top priorities. If there's water ice on Mercury, that's where we expect to find it. After a long cruise, Bepi Colombo is on the final stretch to unlocking the secrets of the solar system's innermost planet.
And that is all the time we have for today. From setbacks at Starbase to stealth storms, and from raccoons to revelations on Mars, it's been a busy time in space.
It really shows how much is constantly happening both in our own celestial neighborhood and in our efforts to explore it. Thank you for joining us on Astronomy Daily.
Be sure to subscribe wherever you get your podcasts and join us next time for another look at the universe.
Clear skies and keep looking up.